Okay, today, in talking about probability, we're going to talk about two kinds of probability. The first one is what they call experimental probability. This probability is based on a series of trials, and we look for how many times we have a success, and we'll talk more about what that means, out of the total number of trials. So for example, if I'm rolling a set of dice, and I say, what's the likelihood or the probability that I'll roll a total of 5 when I roll 2 dice? The rolling the 5 for the total is the success. And how many times it takes me to roll all of those dice, however many times I roll the dice, that is the total number of trials that I'm talking about. The theoretical probability is mathematically what should happen if we conduct an experiment an infinite amount of times. So oftentimes, when you're conducting an experiment, if everybody in here were to take 2 dice and roll them, what we would find is Dill might find out that her likelihood is 3 out of 100 that the 5 comes up. And Naima might roll the dice and find out it's 7. And Eric might roll it and find out it's 15. So we might all get different results because that's what experimentation does. You just write down what you saw. But in reality, if we kept rolling the dice forever and never stopped, all of us should get the same result. That's called the theoretical probability. Okay, so every experiment could be different, but the theoretical probability is always the same. When you're looking for these answers, what you'll find is that the experimental probability is the number of times you had the success, like for example, rolling that 5, over the total number of trials that you performed. So let's say we rolled the dice 100 times, that's the number of trials. If you got that 5 13 times, that's the success. So your answer would be 13 over 100. In the second part, the theoretical probability is the number of ways the success can happen over the total number of possibilities. Okay, so let's assume that we have two dice. Let's assume that we have a red die and a green die. And let's make a chart based on that. So let's say over here that I have the red die, and then maybe I'll go with blue because blue shows up better. And then over here I have the blue die. If I make a chart showing what happens, it would look something like the following. Let's say on the red die, you know that you can roll a 1, a 2, a 3, a 4, a 5, or a 6. And on the blue die, you have those same exact possibilities. So you could roll a 1, a 2, a 3, a 4, a 5, or a 6. If I roll both of those dice together at the exact same time, and I roll a red 1 and a blue 1, then the sum of those two dice is 2. 1 plus 1 is 2. And if I roll a blue 1 and a red 2, the total is 3. And then a blue 1 and a red 3, the total is 4. I'm adding up the number of dots that I see facing up on the dice. If I continue this chart, this is what you see. So if we continue in this chart, I'm just going to total up the two dice as I go across. So then in the next row, as I'm totaling up the dice, I'll get different numbers, of course. So now the blue 2 plus the red 1, that's a 3, and then there'll be a 4, and then a 5, and then a 6, 7, and 8. And I keep writing down these totals for all the possibilities. So 4, 5, 6, 7, 8, 9. You can probably see patterns. Remember, math is a study of patterns. And then 5, 6, 7, 8, 9, and 10. And then 6, 7, 8, 9, 10, and 11. And then lastly, 7, 8, 9, 10, 11, and 12. And these are all of the possibilities that could occur when you roll two dice. And I wrote them in different colors, the blue and the red that is, so we could distinguish that it's different if you roll a 1 on the red versus a 1 on the blue. They're two different dice. So these are all the totals. And then what you'll know is that if you count up all of these different possibilities, like there are 6 in the first row, 6 in the second, so on and so forth, you'll see that there are a total of 36 possible outcomes. Meaning there are only 36 different things that could occur when you roll these two different dice. And they're all listed on the board. So now if I did that, and I said, hey, what's the probability of a sum equal to 5? What you would say is, oh, where does that 5 occur in my chart? And I notice that my 5, when I'm looking at that possibility, is 1, 2, 3, 4 different 5s in my table. You see them? So then I write down that that probability is equal to 4 things that are my successes. That means getting a total of 5 when I roll the two dice, out of the 36 different things that I could get. That's the probability. Now, of course, you could simplify that and get 1/9. I could ask a different question, of course. Like I could say, what's the probability that the sum of the two dice is equal to 7 And what you'll notice in this chart is that the 7 occurs the most times. So for anybody who's familiar with the game of craps in Vegas, that's why they use the number 7 for some things, is because it's the most likely outcome. And so this is a total of 6 successes out of 36 different possibilities, which if you simplified it would turn out to be 1/6. And you can always write it as a decimal if you want to, so 6 out of 36 is the same as 0.16 repeating. About a 16%, 17% chance. You can just leave it as 1/6, that's fine. Probabilities, for your information, are always between 1 and 0, whether you write it as a fraction or as a decimal. If you like, and if they ask you, you can always write it as a percentage. So I could say 1/6, I could say 0.16 with the 6 repeating, or I could say 16.7%. All three answers are acceptable when they ask for probability. Decimals, fractions, and percentages. Sometimes they calculate probability with